That's how we imagined the y's were created, because Mother Nature had the design points given her, she knew the thetas and the kappas, and she produced the y's, and so that accounts for how the observations were produced. But as a human being, I see the very same mathematical expression in a different way. And just to indicate the real difference between the point of view, we're going to call the same mathematical expression a likelihood function this time. And look how we read that. We say that it's a function of the thetas and the kappas, the unknown parameters, if you will, given, see that vertical stroke still standing for given that we now have the observations y, and we now know what the values or the settings of the control variables happen to be. And so this is how we look at our particular problem. And what we're really going to try to do, we're going to try to arrange things. We're going to deal with the y's and the design of experiment. We're going to try to arrange things so as to maximize this quantity. We want to find values of theta and kappa, if you will. We want to find the values of the parameters in the model and the parameters in the error distribution, such that we make the event. That's the thing that happened to us. We want to make the event most likely. We want to get the probability as large as possible. Well, if you were going to get this particular expression to be as large as possible, what would you have to do? Well, you'd have to plug in the mathematical model for eta right up here, and then you'd have to arrange the choice of your theta such that this particular exponent up here was as small as possible. So our problem actually is to choose the values of the parameters so that this exponent up here is as small as possible. Making that exponent small will make p of y large, and that's because of that little minus sign standing there. So we're going to try very hard to minimize this particular function.